Alright guys, welcome to our channel. If you are new, please subscribe for more content. So this time we're going to talk about parallel circuits. This is under DC circuits. So parallel circuits, or also called as parallel connected resistors, will basically look like this. So we have a voltage source right here. This is DC source. This would be our total voltage, and then we have a couple of resistors. We have R1, R2, R3, and then Rn. N represents any real number, so we could basically connect any numerous resistors right there as long as it connected in parallel. So the reason why this is called parallel circuits, because if we try to look back in our geometry, or if we try to think of parallel lines will basically look like this, two lines that will never meet. So if we try to think of this one, R1 and R2, also R3 and Rn, they are all connected in parallel lines like this. This is parallel, and also this one, and then this one. So that is basically the reason why this is called parallel circuits. So let's talk about the total resistor or total resistance of these circuits. Let's put RT right here. So in terms of total resistance, this is different from series circuits because we do not add all of the resistors right here. Instead, we will add its reciprocal. That's 1 over R1 plus 1 over R2 plus 1 over R3, and then plus so on and so forth 1 over Rn, and then we have to raise all that up to -1. So by using this formula, we will find the total resistance of this parallel circuit. So we could also use another formula like this. We can have 1 right here, and then 1 plus R1 plus 1 over R2 plus 1 over R3, and then plus so on and so forth 1 over Rn. So we can either use this formula or use this formula. We will come up with the same outcome, which is the total resistance. So that would be the total resistance of the parallel circuits in comparison to the series circuits. Series circuits is just R1 plus R2 plus RT plus Rn, which is quite different from the parallel circuits. So when we already have the value of RT, so right now we can find its equivalent circuit. So if we already find out the values of RT, our circuit will also look like this. If you try to redraw, we have a positive and negative. This would be VT, and then in connection, sorry, let's put this. Since we have already the value of RT, assuming that we really found out, our circuit will basically look like this. So we have RT. Let's just close the circuit. This would be our RT, and then the current will flows through here. This would be IT. So right now, if we already have the value of RT, this circuit and this circuit will the same. This would be its equivalent circuit. So that's just for highlight. How about the total voltage? So total voltage, based on Ohm's law, we can also use if we have the total current multiplied by the total resistance, or in parallel circuits, whatever values of the total voltage right here will be equal to the voltage that is flowing through R1, R2, R3, Rn, and then so on and so forth. Therefore, Vt is also equal to V1 equals to V2 equals to V3, and then equals to so on and so forth Vn. That's the reason why in parallel circuits we have constant voltage. So whatever values that we have here will equal to the voltage that flows through here, right here, and then right here. They are all equal. Let's call this V1, V2, since that is the voltage flowing through resistor number 2. Let's call this V3, and this Bn. That would be it. So How about trying to find the value of the voltage 1? So value of voltage 1, we can use the formula of I1 and then multiplied by R1. Also, in terms of V2, we can use the value of I2 and then R2. So the reason why we put I1 and I2 right here, because in terms of current in parallel circuits, we do not have the same value of current. Instead, in parallel circuits, we have the same value of voltage. That's why we call this constant voltage. So that would be for the voltage and the voltage being supplied to its resistors. How about the current? So let's use current right here. Current will, in terms of Ohm's law, we can use VT, or the voltage over total resistance. Or if if we try to analyze this, the flow of current from positive to negative, that's the conventional current flow. Let's call this IT. So based on this junction, or we call this node, they are the same. If we try to watch the if we try to okay if we try to based on this junction, if we try to follow the flows of current will split up in two ways. So there will be current flowing through right here, we call this I1, and then also right here we call this I2, and then through here I3, and then of course right here IN. So that would be it, meaning that we have different current flowing through each of the resistors. So how about trying to find the value of I1? So let's find I1. Using Ohm's law, we can use V1 or VT, since V1 and VT are equal, divided by R1. This time we're going to use R1. And then I2, we can use also VT or V2, since they are the same, divided by R2. Or I3, we can use VT over R3. And then IN, we can use VT over Rn. So that would be how to find the current being flows through each of the resistor. Or in terms of the total current, we can also use this formula if we have already the value of all the current that is flowing through each of the resistors. We could also use this formula for finding the total current. That would be I1 plus I2 plus I3 plus so on and so forth. That would be IN. So that's it, guys, for the three important parameters. We already have how to find the total resistance of the parallel circuits, the total voltage, and then the voltage also flows through each of the resistors, and then we have also the total current, and then the current flowing through each of the resistors. How about the power? So in terms of calculating the power in the parallel circuits, that is also the same in terms of calculating in the series circuits. So we have PT. Let's call this PT. We can either use, if we have the value of VT already, VT multiplied by IT. So we can use this, or also we can use this one. If we have the value of IT, let's put that into the squared, and then multiplied by the value of RT. Or PT is also equals to P1 plus P2 plus P3, and then plus so on and so forth. So power 1 will flows through here, power 2 also right here, power 3, and in the power N. So that would be the formula that we're going to find in terms of finding the power total. So how about finding the power 1? Power 1, using this formula, we can use VT, since V1, we could also use V1, since V1 and V2 or VT are equal, so we can use also VT. Let's multiply this by I1 if you know already the value of I1, or we can use this formula, I1 squared multiplied by R1, of course. And then finding the P2, the same also, we can use V2 or VT since they are equal, and then that would be I2. or we can use I2 squared and then multiplied by R2, of course, and that is also the same to P3. We can use Vt multiplied by I3 or I3 squared multiplied by the resistance 3. And then in Pn, we can use Vt multiplied by In, or that would be equal to In squared multiplied by Rn. So that would be the power, the formula of power that is being dissipated into each of the resistors. So that would be the power, or the P1 and P2, or the power that is being dissipated in each of the resistors. So that would be in terms of power. Right now we already have the four important parameters in terms of analyzing the parallel circuits. Alright guys, so that would be for this video. I hope you understand well the topic, and then for our next video there would be two examples with regards to parallel circuits. So please watch that for to understand well our topic, and then that would be it, and then thank you for watching.